Hello viewers, welcome to my channel KK Concepts of Electrical Engineering.
General equation for polarized uniform plane wave. Let a uniform plane wave be traveling in the x direction. Let electric field intensity E equals to two components, that is EY, UY plus EZ, UZ. Let this be equation 1. And E is represented mathematically that E equals to E naught e to the power of j omega t e to the power of minus j beta x. E naught is the amplitude. Then let delta is the phase angle between EY and EZ. Then let EZ equals to E1 e to the power of j omega t minus beta x, and EY equals to E2 e to the power of j omega t minus beta x minus delta. And this component is derived from the above equation. Substituting these two equations, let this be number 2 in 1, we are going to get E equals to Ez. So E1 e to the power of j omega t minus beta x uz plus E2 e to the power of j omega t minus beta x minus delta of u1. Let this be equation number 3. This equation is true for all the values of x. So if x equals to 0, E equals to E1 e to the power of j omega t, x is 0, so this term is 0, uz plus E2 e to the power of j omega t minus delta, beta x is 0. This is along u1. This can be written as E equals to E1 cos omega t plus j sin omega t of uz plus E2 cos omega t minus delta plus j sin omega t minus delta of u1. Let this be equation number 4. Now, comparing equation number 1 and number 4 and taking the real components only, then you are going to get EY equals to E2 cos omega t minus delta, and EZ equals to E1 cos omega t. From this, you can write EZ by E1 equals to cos omega t. These are the equations we got, from which EY by E2 equals to cos A minus B is nothing but cos A cos B plus sin A sin B. So cos omega t cos delta plus sin omega t and sin delta. Now you know that cos omega t is this one. So is that by E1 cos delta plus sin omega t, you can write 1 minus cos omega t and sin delta. Cos omega t is again Ez by E1. So this you can write Ez by E1 cos delta plus square root of 1 minus Ez by E1 whole square sin delta. From this, Ey by E2 minus Ez by E1 cos delta equals to 1 minus Ez by E1 whole square under the square root of sin delta. Now, squaring on both sides, Ey by E2 whole square plus Ez by E1 whole square cos square delta minus 2 Ey by E2 Ez by E1 cos delta equals to right hand side 1 minus Ez by E1 whole square sine square delta. Now multiply this. This is sine square delta minus z by a1 whole square sine square delta. And you are going to get ey by e2 whole square plus ez by e1 whole square. The term is cos square delta, and this term, if you get from to the left hand side, then the same term with sine square delta minus 2 ey by e2 ez by e1 cos delta equals to sine square delta. Now this term is 1 ey by e2 whole square plus ez by e1 whole square minus 2 ey by e2 ez by e1 cos delta is equals to sine square delta. And this is a general equation of sine wave which is polarized in x direction, and this can be applied to linear polarization. So condition for the linear polarization, the phase shift or delta must be equal to 0, and the e1 e2 may or may not be equal. So if you substitute this in the general equation, you are going to get ey by e2 whole square plus ez by e1 whole square minus 2 ey by e2 ez by e1 cos 0 is 1 is equals to 0. ey by e2 minus z by e1 whole square equals to 0, from which you can write ey by e2 equals to z by e1. Or simply you can write ey equals to e2 by e1 of z. Amplitudes are constant, so this value is constant, so we can write this as ey equals to a constant, let this be m is z. This is in the form of y is equals to mx, which represent a straight line. Hence the general equation can represent a linear polarized wave. Hence circular polarization. The conditions that e1 must be equals to e2 and delta equals to 90 degrees. Substitute this in general equation, you are going to get ey by e2 whole square plus ez by e1 whole square minus cos 90 is equals to 0, so this term will be 0 equals to sine term is 1. In this equation e1 e2 are equal, so you can write this ey square plus ez square equals to 1 time of e1 or e2, whatever it is, let it be e2 square. This equation represents the equation of a circle. Hence the general equation can represent a circularly polarized wave. Hence general equation. Elliptical polarization. For elliptical polarization, the condition must be delta 90 degrees. Then substituting this condition in this, you are going to get similarly ey by e2 whole square plus ez by e1 whole square and 90 degrees. So this term will be 0 and this term will be 1 equals to 1. And this equation represents the ellipse. Hence the general equation.
If you have any suggestions and queries, please mention in the comments. If you like this video, please like, share, and subscribe. Thank you for watching the video. Please stay tuned for more videos.